This project is related to transient dynamic analysis of Kirchhoff's plate using an explicit finite difference method in MATLAB. Which is basically in the abstract, I have just written how the dynamic behavior of plastic plates for the critical concerns in structural aerospace with mechanical engineering applications. And basically, this method is proposed by the Bonaldi et al. Okay, he was a scientist who solved the Kirchhoff's love plate blending bending problems. So that's why he just generated that how biharmonic operator governing plate bending in the discretized through a fourth order center difference scheme. So in this article we have just proposed like how the Gaussian dynamic loading is imposed at the plate center to evaluate the transient fluctual, fluctual, fluctual response under the localized excitation according to how we just added the boundary condition to implement the validate classical plate vibration behavior. So Nine was one of the scientists who present the stable and accurate mechanical numerical methods for the generalized Kirchhoff's love plate, Kirchhoff's of love plate. So here is I have just added the keywords with the introduction. In the introduction, you just need to check that the fundamental importance in the numerous engineering disciplines, including the aerospace structures with the and the Fogang was one of the scientists who applied the finite difference method to analyze the Kirchhoff's love plate theory, and also the mathematical foundation for modeling of small transverse deflections in thin plates. So yes, in the simplicity, accurate implementation of high-order spatial derivatives poses challenges, um, especially when the simulation of the localized excitation and forcing realistic boundary constraints. So in this introduction, I have just explained in details like what previous scientists did and how the Kirchhoff's law plate is working according to the deformation pattern with the mode interactions with the transient vibration of the characteristics of the plate. Okay, so here is that this basically is the formulation of plate in Kirchhoff's law plate. Importance of plate dynamics applications here in which I have added its plate with the material properties in terms of table and the classical Kirchhoff's law theory, also the comparison of classical theory with the biharmonic operator and the uh, effects of analytical solutions accordingly. Okay, just a second, let me just open the MATLAB for the demonstration as well. I think MATLAB is in crash. Okay, so here is the numerical challenges with the FDM advantages as well. So here is a figure which contains a finite method in Kirchhoff's of transformation, and these are the numerical settings with the table defined. Okay, so here is the significance of dynamic simulation with the mode of transient dynamic simulations, which provide us the complete solved clamped Kirchhoff's law plate, Kirchhoff's of plate bending problems using the superposition of sinusoidal and polynomial basis function. Here is a contribution of present work. Basically, I have just added how we have tested the under localized Gaussian load applies to the plate center with the generating of realistic transient deflection patterns and enabling the visualization of vibration mode as well. So here's some background and motivation I have added with the numerical methods and its challenges. Basically, our main aim is to find out the approximation of biharmonic operator, ensuring the accurate representation of flexural stiffness with its curvature effects. Okay, so here's a problem statement. Problem statement is like how we need to check that the dynamic behavior of the plate according to the Kirchhoff's of love equations, and how its geometric and idealized boundary conditions are insufficient for the practical engineering problem solving. And we need to check that the Kirchhoff's of love plate, how accurately predict the transient response of plate under the highly fidelity numerical methods capable of resolving fine scale deflections as well. So here is a mathematical approach. These are the mathematical equations will be used, which I have used in that MATLAB algorithm with the using of CFL criterion as well. And methodology is also written here, and in terms of initial conditions, in terms of Gaussian displacement applies to the plate center of simulation, transient excitation, and the design and MATLAB simulation with the it's a summary like how we use the parameters of simulations, and with the output results. Basically, these are the final plate displacement with the contour plot of the distribution, spatial distribution of bending under the center of plates. Mesh representation of Kirchhoff's law, Kirchhoff's of plate with the color map of deflection of the magnitude and spatial distribution, and the deflection along the plate center line. These are the results with discussion and the conclusion as well as the references. Let me just run this Kirchhoff's of plate algorithm. Okay. See, these are the output results of deflection plate center line with color map of deflection with the map representation of plate deflection with the final plate displacement contour plot as well as the final plate displacement surface plot. Okay, so these are the MATLAB code in which all the sections are defined with the comment section as well. You just read it and you will understand all the sections clearly. Okay, thank you.